Okay, welcome to the second video looking at immutability and mutability, but in this case we're looking specifically with relevance to functions and what happens when we pass variables into functions. So I've already pre-written some code here just to get us off the ground. Obviously I've got my call to main as normal at the bottom and my main function up here, that's where everything runs from. You can see I've defined a new function called myFunction down here at the bottom, and I'm calling it here from within main. So let's have a look what's going on. I've set up a couple of three variables. I've got an age, which is obviously an integer variable. I've set it to 10. I've got a name set to the string Duncan, and I've got some attributes. I don't know what they mean, but it's a list and it contains 1, 2, and 3. It doesn't matter. And what I do is within the main function, I just print the string age, name, and attribute so I can see what they are. I print their IDs. So this is kind of the reference to them, kind of the equivalent of where they are in memory. And obviously I print their values. I then call the function. I call the function passing in firstly the age variable, which is obviously 10, pass in the name variable, which is obviously Duncan, and I pass in the attribute variable, which is obviously this list 1, 2, 3. Okay, looking at the actual function itself, when I've defined the function, I've told it it's going to expect 3 attributes passed in, and I've called the first one num, I've called the second one string, and I've called the last one lst. Now, first of all, there's a bit of debate about here. Why are these got different names here within the function from within main where I call them? Well, there's no strict guidance on it, but suffice to say, if the variables have got a specific meaning within your main function, as I've tried to indicate here, this variable age is the age of the person, this is a string representing their name, and these are some particular attributes. But I call this function, and within the function I don't really care that the first thing is an age. For me, within the function, it's just a number and I'm going to do something with it. The second thing is just a string and I'm going to do something with it. And the third thing is just some list of numbers and I'm going to do something with it. It's difficult to generalize, but clearly this function could be doing anything. And we might call it later on where the first number here that we pass in is not an age but a height. The second function is not somebody's name, but a string of an address. And the third thing is not a list of these particular attributes, but a list of some other attributes. So within the function, we just use the general idea of what they are, rather than the specific idea of what they are within main. Things like this will come out more as you learn more about programming. Suffice to say, it doesn't really matter at this stage, the fact that we've used different names here to what we've used within the function, or indeed I could have used the same names. The whole process will work. What do we do within the function? Well, we've called the function and we print out the 3 parameters that we've passed in. We print out num, string, and list. We print out their IDs and we print out their values. So let's run that program and see what happens. Okay, let's just have a look at it. So age obviously goes in with a value 10 to start within main, and down here within the function num gets a value 10, so that's passed in correctly. The variable name Duncan is up here, it's in the variable name in main, and when it's passed down here into the function we've called it string, and that's still Duncan, so that's good. And the list 1, 2, 3 is attribute up here, and there it is, the list 1, 2, 3. And when we pass it into the function, it's now called LST, and it's got the values 1, 2, 3 in it. Okay, not particularly exciting. Do we really care? That's exactly what we'd expect to happen. But of interest, just look what's happening with the IDs. So the ID of age out in main ends 744, and when we pass it into the function, the ID of num is the same ID. And the string called name out in main ends 8400. And here's a string within the function ending 8400. Obviously the first few digits are the same. I'll leave you to read those. And similarly, the attributes here, whatever this list refers to, is 45519376, 45519376. So interesting enough, when we've passed all these things in and we've created these new labels, num, string, and list, they're actually pointing to the same bits of memory where the code's stored. So let's just have a look at that on paper so we make sure we understand what's gone on there. Okay, so let's have a look at this from a memory point of view. What do? We set up age being 10. we set up name being Duncan, and we set up attributes being our list 1, 2, 3. And as we've already looked, what's actually happened is in memory we've got 10 and our reference age points to 10. We've got our area in memory to put in Duncan, and our name points to there, and we've got our area in memory where I've got 1, 2 and 3 and my attributes point to there. So we were running fine in main. We then went and called the function my function, and remember the way that we pass stuff in. We pass stuff into my function, and when we define my function, what we were passing in were called num, string and lst. So what actually happened? Well, within my function down here, it created the labels num, it created the label str, and it created the label lst. But even though we've taught often that it copies this value 10 down into memory and this now accesses it, and it copies name down and it copies the list down, what we've just seen from looking at the code is quite clearly all we do is we get the label to point to where the information is in memory. So it's still pointing to exactly the same data in memory as it was up in main. Now again, it wouldn't have mattered if I'd called it age up here in main and age down here within the function. This label is local to the function, and only within the function have I got access to these labels. So these are local to my function still. Don't get confused thinking that it's only because they've got different names. It's not that if we'd called this age, we'd still be using this label up here, age. It would be a new age down here, local to my function. So that's where we're at the moment. Num, string and list all point to the same data in memory that they did when it was back up here in main. And what that means is it's incredibly efficient to call a function here, because even though we teach that all this data is being passed into these new variables, it's not really. All we're doing is we're creating 3 new labels and we're pointing them to the labels of where this was called from. Okay, so obviously, to clarify that, this is our def statement. So these are our new labels within the function. Okay, what we need to do now is understand what happens when we start playing with the variables from within our function. So we're back here in the code now. What we want to do now is from within our function, I want to go and change each of the variables locally within the function. So num1 within the function, I'm now going to make 20 because I think I've got a year older. String, for whatever reason, I'm going to go and change to Fred. And my list, I'm going to add something else onto the end of that. So list.append 4. Okay, and then what I'm quite interested in is to see what's happened to the variables that I have altered. So I'm going to reprint them out from within my function. So we're going to get things printed out quite a few times, so I think we just need to make it a bit clearer about what's going on. So here we need to say print at start in main. So that's going to print that we're going on at the start. We're then here in the function, so I better print in function. Then still within the function here, but I've altered the variables, so I'm going to say print in function after alter. That's after I've altered the variables. And lastly, obviously, we get to the end of the function here. It's going to go back into main. So this is where I call the function. It's going to go back into main, and I think what I'm interested in is to say what happens when I get back into main. So back in main. That's obviously the last bit that will be printed. What do I want to do there? I want to print all the same things again. Okay, just get my indentation sorted out, otherwise that'll give me an error. So just to reiterate what we're doing, we're setting up the variables, we're printing them, we're passing them into a function, passing all three in. We've got different names, but within the function we're printing them out. We're altering all three within the function. We're just printing out what they look like before we leave the function, and then when we go back into main here, we're printing them all out again. Obviously now with their IDs that are back in main, from within here at the end, we couldn't use num, string and list because they're not available. They're only local to the function. So let's run that. Hope I've not made any stupid errors. Fantastic, that's run. So let's have a look at this in detail and see if we can understand what's going on. So just like we had before, age starts with the value 10, 744. Once we go into the function here, we passed it in, now we call it num. It's still the same place in memory, 744, and it's got a value 10. But in the function after we changed it, okay, so I've screwed up there because I've actually called it num1 within the function here. I've created num1 as 20, so that ain't going to help. Right, let's just edit that. Okay, num20, it was called num. Rerun that. Okay, let's just get the window a bit more up to the top so we can see it. I was wondering what the hell was going on then. So again, age starts off with 744, the value 10. In the function, it's 744, it's got the value 10. In the function here, after we've now changed it, you can see it's changed to the value 20. And yes, of course, the reference has changed because it's an immutable object. So when we've changed it to 20, it's not changed where num was pointing, it's made num now point to somewhere else, and it's got the value 20. So clearly when we return back into main, well, we haven't messed around with age. Age is still in the location 744 and it's still got the value 10. So that ties in with everything we know. We pass stuff into a function. If you mess with it in the function, it doesn't change back in main. So that all ties in. If we look at the string, what's going on there? Well, here we've got the string called name. It's in 1104 and it's got Duncan in. We go into the function. We've now called it string. So string refers to it. It's 1104. It's called Duncan. We then go and alter it. The string after the alteration here is now called Fred. And hey presto, of course, it's in a different location, just like we'd expect, because it's immutable. Strings are immutable. We can't change what's in this memory location, Duncan. So we just make string point somewhere else and we put Fred in there. And obviously, therefore, when we go back into main, name is still pointing to 1104 and still contains Duncan, exactly like we'd expect. So what was the point of all this? Well, let's look at the list. So here's our list, its attributes. It's 9584, it's got 1, 2, 3 in. We pass it into the function, and within the function it's still in the same place, 9584, 1, 2, 3. But when we alter it and when we append 4 onto the end, because lists are mutable, it actually changes what list points. It actually changes the memory that list is pointing to. So list is still pointing to the same location, 5984, and we've added a value onto that list. So because now list and attributes are pointing to the same location, because it's mutable, when we go back into main, attributes is still pointing to that same location, but it has changed. And that's the unexpected behavior that catches a lot of people out. So what's the long and short of this? Well, basically, if you pass an immutable object into a function, you can do what the hell you want with it in there. Change it, it won't make any difference. Because if you alter it, a new copy will be created and the original will be left alone. However, if you pass a list into a function, and within that function you change it, or you pass a dictionary into a function and within the function you change it, then you've changed it back in your main program as well. because a function is operating on the same list, because it's mutable. We're allowed to change it. And in fact, as you start designing Python programs, you'll find this is a really useful behavior. It would be daft if you needed to alter a list to have to create a whole copy of it, pass it into a function, do something with the copy, and then pass it all out again as a return. It's much more memory efficient just to pass a reference into the list into the function in knowledge that the function has the ability to change a list and doesn't need to explicitly return it because it's got a pointer to that same location. Well, I hope that made sense. It's one of those really difficult areas to get your mind around the first time you come across it, and if you don't, it might catch you out in the future. Good luck and happy Python coding.